Greetings of the day. Welcome to the course on Operations Research Technique. Students, we are in unit number 4, and in unit number 4 till date, till this time, what we have studied is what is a network, what do you mean by project, big project, what is the role of activity and event in a project, how project is executed, how network is constructed from given logical relationship that we have seen. Now when we want to analyze it further, that is for different activities, and in last problem, if you recall, the problem was very simple, in which it was asked to find various paths of the given network, then expected project duration of the network, along with one important aspect, that is probability of the network, for completing the project within given conditions. And the conditions given, if you recall, in last problem we have drawn network from logical relationship, and in that particular problem activity were mentioned in terms of event number, like 1 2 1 3 1 4 2 3 2 4, in that fashion. Activity was not named in the form of A, B, C, D, like that. And I have also mentioned that if this is the case, then don't unnecessarily rename the activity, let it be as it is. And we have seen that in PERT network, what is required is we have to calculate activity time. 3 time estimates were given, that is TO, TM, TP. From that, what we did is we have calculated activity time by using the relationship TO plus 4 times TM plus TP divided by 6. This calculation is necessary in PERT activity time. When it is a critical path method network, you will be provided with only one time estimate. There is no need to calculate time estimates separately. Remember one thing, the methodology till finding critical path is same for PERT as well as CPM. In both network analysis, we have to carry out forward pass and backward pass calculation. Quite sure that you have to remember. Now if you recall our discussion in earlier lecture, what we have done is we have evaluated that problem up to the point of finding critical values of different critical values, means critical path values for the given network, and we have estimated it was 17 weeks, if you remember that. And there again in PERT calculation, what we did is, I will just summarize the last problem. The problem was this one. This was the problem asked in last, we have solved in last lecture, and here go through my last video wherein we have drawn logical network for the project. This was over, and then identify all the paths. We have identified 3 paths in that particular network. Determine expected project length. Yes, this TE we have evaluated in last lecture, and it was 17 weeks. Go refer my last lecture pertaining to analysis of this PERT problem. Now this we have already done, and what is now, we were at this point. We have not seen this, what is the probability of the project will be completed. Now this I have explained, at least 4 weeks earlier than expected time. This TE is nothing but it is expected time. This is expected time. Now if you recall, I have given you one relationship, that standard normal deviate z is equal to TS minus TE upon sigma CP. CP is critical path, and for this problem we have estimated this sigma CP for this problem is under root 9, which was equal to 3. This we have already calculated in our last lecture. Now we won't waste our time in again calculating this. You can refer the last lecture how we have estimated this particular value. Now important is this TE. Here this TE we have evaluated as 17 weeks. 17 weeks. What we are supposed to do is we are supposed to find the value of probability. Now if you recall my last discussion, this Z is from that table, normal distribution table, where the value of Z ranges from, I have mentioned there, Z values ranges from Z from 0 to 3.5 and 0 to minus 3.5, and there I have said that this value we have to find from normal distribution table, and I have assured you that this particular table is available in any statistics books or data books. You have to refer that table for finding the value of probability. What we will be doing, what is the methodology? The methodology is that we have evaluated sigma critical path 3, expected time 19. Now we have to find this Z. For finding Z, TS. Now here for this case 4 weeks earlier than expected time, here the TS value is 13 weeks. How this 13 weeks came? Earlier than expected time. Expected time we have evaluated 17 weeks. 17 minus 4 is 13 weeks. For this B case, TS is equal to no more than 4 weeks later than expected time. Again expected time is 17 weeks. No more than 4 weeks. So 17 plus 4, TS comes to be 21 weeks for this case. Within expected time, the meaning is TS is 17 weeks. Now students, what we have to do? We have to keep the value of TS over here. If I put TS equal to 13 minus TE 17. So 13 minus 17 will give me minus 4. Sigma CP is 3. So 4 by 3 is 1.33. So for this case I get Z equal to minus 1.33. For second case, what I will do? I will put TS equal to 21 minus TE 17. So this difference will be positive 4 by CP3. Again it is 4 by 3, means Z value will be equal to 1.33. In first case it is minus 1.33. In second case it is positive 1.33. And within expected time means TS equal to 17. So 17 minus 17 will 0. 0 by 3 will be equal to 0, and therefore Z will be equal to 0. Any number by 0 by any number yields 0. So now what we have to do? For this value of Z, which we have calculated here, we have to find the value of probability from the table that I will show you. You are getting me? We have to find the value of probability for the table from which we will evaluate corresponding value of probability for this number z. Also, I have said in last lecture, if I don't have the table ranging from 0 to minus 3.5, there is no harm. We know mathematical relationship, function of minus t is equal to 1 minus function of t. So 1 minus function of t will give me value of negative z if at all you are not having this particular table. Now keep in your mind three values for which we are supposed to find the value of probability. First value is minus 1.33, second value is 1.33, third value is 0. See, this is also explained, this concept is also explained in earlier lecture. Whenever it is z equal to 0, for z equal to 0, your probability of completion of the project, will be always 50%. Always 50%. When it is within expected time, students, this numerator will be 0. When numerator is 0, 0 divided by any value is 0. For z is equal to 0, from table also you will get probability 50%. So out of these three answers, we have estimated value of answer number, bit number C. Now we will see what is the answer for of probability for A and B case. Similarly, here in fifth bit, what is asked? What should be the scheduled completion time? What should be the scheduled completion time with probability of completion given? Now this is reverse of these three bits. Here in earlier bit, what was done? TS value was given. Then based on TS value, what was asked? You have to find, based on TS value, you are supposed to find the value of z. For z, from table you have evaluated value of what? Value of, from table for z you have evaluated value of probability. We have also discussed maximum probability is 100% in percentage. So in that table we will be given value of probability in form of decimal, suppose 0.99, 0.98. So that value will be treated as, if it is 0.99, we will treat it as 99%. If it is 0.985, we will treat it as 98.5%, like that. Got it? Here in this bit, what we have to do? We have to go in a reverse way now. How reverse way? Now what we will be doing? For 94% probability, first we will find z. For 94% probability, first we will find z from the table. Then from z we will find value of TS. Simple. We know T 17, we know sigma Cp. We have estimated value of z for this 94%. Based on this TS minus T, I got the value of z for this probability. Only unknown is TS. TS can be estimated. We'll see how. Now keep for the time being these three values ready in your mind. Z minus 1.33, then Z 1.33 and Z 0. See how to move ahead. Now here what we will do? See, this is the table. I have said that I will show you one table, and this is the table wherein you can read the value from 0 to, see here you can read the value of z from 0 to 3.5, and further subdivided as explained in previous lecture. Each column 0.01, 0.02, 0.03 like that. Similarly, here you can see on left side the column 0, z equal to from 0 to minus 3.5. So now we are not required to use the value or relation f of minus t is equal to 1 minus f of t. We are ready with both table. So now if you recall, our first case was z equal to minus 1.33. Yes, we have estimated this. Our second case was z equal to 1.33. I have said that keep these values in your mind. And our third case was z equal to 0. And our fourth case was probability was given 94%. What was asked? TS was asked. TS was asked. With this background, now let's move ahead. So first we will see what is the probability for z equal to minus 1.33. Now see here how to check this table. First we know this z column, vertical column, is having two values. These two values 1 point something, and now here below, ahead of this decimal, again 2 digits. Suppose I take one value as 1.3, so here 1.3 is one value, for this plus other value is 0.03. So see, sum of this 1.3 and 0.03 yields me 1.33. 1.33. Of course it is with minus sign, so minus, this will be also minus, this will be also minus, so minus, and this will be minus. Got it? Pay your attention now. Now focus your attention on this row minus 1.3. I am marking this with red color, minus 1.3, this row. So minus 1.3, and what is additional? 0.03. So I have columns 0.00, 0.01, 0.02, 0.03, 0.04 up to 0.09. I need column of 0.03. So this is this is column of interest. Now what I have explained in my last lecture, you have to find the value of intersection of this row and corresponding column. If you go by that method, you get, I have highlighted this particular value. So now for z equal to this minus 1.3, which is intersection of row of minus 1.3 and column of 0.03, I get value of probability as 0.0918, which is equal to 9.18%. So students, this is the answer for first bit, that earlier 4 weeks than expected time. Means suppose the project which otherwise would have been completed in 17 weeks, if you are asked to find its probability of completion, then it turns out to be 9.18%. So what I did is simply 0.0918, I have multiplied it by 100 to convert in percentage. Similarly, now let's see for z equal to 1.3. Now for that again I have to select this particular row 1.3. This is the column of 0.03. Intersection of 1.3 row and 0.03 column yields me this value, and this value reads out to be, for this probability is equal to 0.9082. Again in percentage it is analogous to 90.82%. So answer of second bit we got 90.82%. Got it? Yes or no? Clear? Now third, z equal to 0. I have mentioned in last lecture also, in today's lecture also, that for z equal to 0, by default probability of z equal to 0.00 is 50%. You can see here z equal to 0, 0 and 0, intersection of these two is yielding the value of p as 0.5, which indicates it is 50%. So students, we have evaluated. Now let it be any change. Instead of 3 weeks, if somebody asks earlier 4 weeks, earlier 2 weeks, accordingly z value will change, and as per the value of z you are supposed to find the value of probability. Now reverse way, how to tackle with the situation when probability is given. How to tackle the situation when probability is given. Now here the probability given is 0.94. So what method we have discussed, that here first you have to find the z for 0.94. So for now what do? You know, see all values 0 to 3.5. This is very important point I am telling. For z equal to 0 to 3.5 positive side, values of probability will start from 0.5 onwards to 0.99. So you can see here for 0 to 3.5 z starts from 0.5 to 0.999, approximately 1. Reverse, for z equal to 0 in negative sign, the value of minus 3.5 will go up to 0.000023. So as good as equal to 0. So we know probability ranges from 0 to maximum value 1. Now since it is 0.94 is nothing but 0.94, and at just x place 0.94 will be available in the table of 0 to 3.5 positive. Now this is the table, right hand side is the table of 0 to 3.5, left hand side is the table of 0 to minus 3.5. So what we will do, we will try to find the value of where this 94 or very close value to the 94. Sometimes it may be possible that you won't get exact value in the table. So in that case we will see the value which is more closer. The technical way is, other correct method is you have to interpolate the values, that take two values and then find the mean of that other value. So instead of doing, what we will do, if this is not available, the general method adopted is you go for closer value, which is the value of probability given. So let's check 0.94. So 0.94, here it is 0.9474, here it is 0.93, 0.93, 0.94. Yes. So here you can see two values. one is 0.9394 and other is 0.9406. Now the difference of these both two values from 0.94 is 6. Here is equal, here it is of 6, here it is also of 6. So we can take as such any value, but if the difference is varying, then you have to select the value of minimum difference respect to given value. So suppose here now we take for this 0.9406 means this. So now for 9406, which is closer to 90, because if I read it in percentage, it will be 94.06. If somebody takes this value, it will be 93.94%. This value is 94.94%, this value is 94.06%. So we have taken this value. Now if I read value of Z for this, so Z turns out to be, how to read Z? See here, for this row wise value is 1.5. For this value, row is 1.5, column is 0.06. So students, the Z value turns out to be 1.56. Now you know the formula. What is the formula? Z is equal to 1.56. That is final now. If this is done, then we can go again back for the relationship. The relationship is Z is equal to, what is the relationship? Z is equal to TS minus TE upon sigma CP. So it will be nothing but equivalent to 1.56. 1.56 is equal to TS minus T is, recall the value, T is 17 minus 17 upon 3. What will happen? What will happen? These 3 will be multiplied by 1.56. So it will be around 4.5. It will be around 4.5 something value. And now for TS we will take these two left side, so minus minus will become plus. So ultimately what we get, value of TS as equal to, multiplying this with 3 and adding 17, near about 4.5. So 17 is 21 point, approximately I am writing 5-6 weeks. Calculator, if you do with calculator, you will get exact value. So the logic is, now we are clear with that how to find the value of scheduled completion from the probability given, or how to find the value of probability from scheduled completion time given. So we have solved that problem in a lengthy problem, in all, considering all important technicalities and how to use this particular normal distribution table, which is available in any statistics books. So now this was our problem. Now suppose in this particular problem what was given is activities in this category. Activities were given in this category of like this. Suppose we go one step ahead. That problem definition says activity name of activity and preceding activity. Suppose I am given activities A, B, C, D, E, and it was mentioned like this is dash, this is like this, and suppose this is the case. And now we know that further there will be various activities, values TO, TM and TP. Now how to tackle this situation? Preceding activity is given. We have seen that network is based on precedentship relationship, if you recall our earlier lecture. And I have also quoted that any network will have only one starting event, only one end event. That is also called as terminating event. Now here I have given dash for this first activity. It is not necessary, depending on the project, any in between activity or even last activity, whatever the demand of the project will have dash activity. Whenever you find against preceding activity, against that activity under preceding column dash means that particular activity will not depend on any activity, meaning it will start at once. Suppose I get dash in front of 3 activities, meaning in that particular network 3 activities will start simultaneously. Suppose I get this dash at 2 places, it means 2 activities will start simultaneously. Again, don't do the mistake of starting activities like this. Never. Clear? So now, other name, technical name to this activity, if one is not giving it in the fashion of dash, what they will give is, they will mention that that particular activities are concurrent activity. When it is mentioned in the problem that such and such activities are concurrent activities, the meaning is they do not depend on any activity. So in this simple logical relationship, if we understand this basic concept, we can apply this particular concept to any problem. Now here suppose, now looking at this, we are not bothered of these timings, because ultimately from this timing what we are supposed to calculate is by using the formula T is equal to 4 times TO plus 4 times TM plus TP by 6. That logic is required of calculation of TE for finding critical path. Before critical path, if your network which you are drawn is not correct, your entire efforts are wasted. So as a student, you must practice thoroughly many a times drawing correct logically or logically correct network from the given precedence relationship. Now here I can see A in front of A dash, means how one should read A depends on preceding activity, or other name to this is, other name you will find is depends on. You will get both terms in textbook. It is, one is depends on, other is preceding activity. Meaning, see here, A depends on dash, means A does not depend on any activity. B depends on A, clear? C depends on A, clear? Similarly, A preceding activity, dash no preceding activity. B under the column of preceding activity, A means B, for B earlier A should be finished. This is one aspect. Also, we have seen this relationship in the form of B greater than A, or same thing can be written as A less than B. Do you recall this logic? Yes? Clear. Now, if this is the situation, then how I should proceed? See, very important. Since it is not depending on any activity, I will draw a simple network for this. A dash A does not depend on any activity, dash. Now, see, you adopt one methodology that whenever you draw activity, tick mark that, okay, you have considered this particular activity. Now, here, today I will be teaching you how to cross-check your network once you draw, whether it is correct or not. So, yes, I have drawn this. Now, see which are the further following activity to which you have already drawn. So, when you have drawn A, look to the column of depends on or preceding activity and see for activity which you have drawn, which are the following activity. So, here you can see B and C. So, your task will be now to give further activity B and C. So, I have drawn B which depends on A, B which depends on A, yes, I did it. Then I have drawn C which depends on, I have drawn C which depends on A, all again I have drawn this. This is cross-check mechanism, how to adopt to avoid mistake in network drawing. That's what I am explaining to you. Now, my task is to draw activity D which depends on activity B, activity E which depends on activity C. Activity D, now again go back, B is drawn. So, see which the activity which you have already drawn, which is the following activity for B which you have drawn, B is D. So, your task is to further D. Then I have drawn this. C I have drawn, yes, C I have drawn. E is depending on C. So, depending on C will be E. Clear? I have drawn this. Now, this is very important point, very important step. Let me give more emphasis at this particular place. Student assume that network is over. Student assume that this particular network is over, which is totally wrong. Remember my statement that any network will have only one starting event and only one end event. Whatsoever is the complications in the network, any network will have only one starting event and only one end event. You know that? Yes. So, definitely this is wrong. Intentionally I have drawn like this. This is wrong. So what is correct? How one should avoid mistake? So for that, keep one thing in mind, that whenever, this is very important statement I am making now, very important statement from my side, whenever there is no successor activity, whenever there is no successor activity to the activity which you have drawn, now you have drawn activity D and E, there is no successor activity, those activities will be your last terminating activity, which must be terminating at one node. And students, this is correct network now. What I said, I will give you methodology how to cross check. We have done tick mark up to this point. Now what as a student I will do before going for actual PERT calculation, because why I am emphasizing on this point is, if your network is wrong, your entire efforts will go waste, quite sure. So give some time to confirm the network you have drawn is correct. Let's check. Hardly takes a minute, not minute, seconds. A independent dash A starting activity, B depends on A, B depends on A, yes, double check. C depends on A, yes, my network is showing. D depends on B, yes, my network is showing. And E depends on C, yes, my network is. This is how I have cross check my network. So what happened? Ultimately I got correct network. Otherwise what mistake I would have made? I would have end this with 2 nodes, or if there are 3 activities, 3 nodes, which is wrong. And now you know one method of numbering the events, left to right, top to bottom. Suppose we want to number this particular network. Suppose, let's have again the practice. So we know, count the number of events, 1, 2, 3, 4, 5. This is our location of event number 1. This is last 5. Let's write it correctly. This is 5. Then left to right, top to bottom. So 1 followed by 2, left to right. 2 is giving branches, 2 branch. So only 2 are remaining. Left to right, top to bottom, 3, 4. Now here in earlier problem, activity was given in terms of event numbers, 1, 2, 1, 3, 1, 4, like that. Here activity was posted in the form of alphabets, A, B, C, D, like that. So we have written name of activity above the arrow. Suppose timings are given, calculate these timings for all 4 activity, put that below. Forward pass, find T, then find TL, backward pass, find critical path, the same method. Got it? So this is how in real sense entire PERT problem is solved. So for PERT problem, what important point you have to keep in mind? You have to draw correct logical network first, then find activity time. Now this is to be practiced. Number of problems can be created by changing the positions of the activity. It is, you will become master in drawing network only after solving number of problems. This is the clue, this is the hint which was given. Now Then next is you have to find T. Once you find T, find critical path. For that, find slack. Once you find critical path, find variance of critical activities. Then find standard deviation of critical activity. Once that is over, we use the relationship of T Z is equal to Ts minus T upon sigma C. Once that is done, find from the table the values of probability, or from the probability value find the value of scheduled completion. So this is how we go for PERT problem. So today we'll stop at this point of time, and from next lecture we'll go with the evaluation of further part of project management. So till now what you can do is you can practice the network for its correct logical drawing.